Good evening, my name is Jeremy Hampton. Today we're going to be looking at the topic of UDU substitution. And when we are looking at this specific equation, you can see that it would be really unpleasant to find the integral of this function with a power like this in the equation. So we are going to use a method called UDU substitution. The first thing we are going to do is we are going to find a u, which is usually something that is raised to a power. So we're going to, in this equation, the u would be classified as x cubed plus x squared. So over here we're going to write down u is equal to x cubed plus x squared. And now we are going to take the derivative of this function, of u, not the function, of u with respect, derivative of u dx is equal to 3x squared plus 2x. Let's rewrite that. 3x squared plus 2x. Alright, and then we are going to write in. And then after we're done with that, we're going to take this dx and we are going to multiply it over and put it over here. dx. Okay, and that takes that out of that. Alright. So now, after we have taken the derivative of du, you can see that the derivative of du is convenient in this equation, and you can see that this right here, the 3x squared plus 2x dx, is actually found in the original equation, 3x squared plus 2x dx. So after we do that, we are going to rewrite the equation, and I will rewrite the equation in different colors to show where the substitute to. Alright, you can see now that I've rewritten the equation, so you can see where u is right there, and the derivative of u is right here, and those will be able to be substituted correspondingly. The important clarification at this step in the equation is that this power to the 7th is not equal to u. So the power of this part of the equation to the power of 7th, the 7th power is not part of u. That's an important clarification. Going on to this, we are going to sub these in with their respective counterparts. As we do that, we can write it out. Go like this, the integral of du, we'll go ahead and put du first, or let's make that blue. It's more clear. Nope, wrong blue. Du. So that's from that and that being sub for that, because that's set equal to each other. To now, here's where the 7th, the u and the 7th power come back into play. So the u will be green, u to the unrelated but now related 7th power. Alright, so now we can take the integral of this function now that we have all these components in place, because now it would be a standard practice and easy to do. Okay, now that we have taken the integral of this function, we can see that u can be subbed back in to make it so we can get our final answer to this, the integral of this function, or the reverse chain rule. So now we can go in and make that green so you can follow along. 1/8 times u, which is now going to be replaced with x cubed plus x squared to the 8th power plus the constant. So now we can see that we have subbed back in u from this original equation back in for that u over there. And this all came from taking this out, subbing out, taking the integral, and taking the du. And then, so if this was not directly equal to the derivative wasn't the same outside of this, you can manipulate du, so you can move a constant out in front and change that. That'll be reviewed later in this video with non-derivative parts in the equation. Thank you for watching this segment of the video on a basic explanation of u/du substitution, and you can see how it is done in color format. You can follow along. So u was subbed for here, u was found from here with that power, and then there's the derivative was taken with respect to u, and you can find that part in the equation over there. Those were substituted. This was taken the integral of, and then the u was subbed back in to the equation to get our final answer, 1/8 times x cubed plus x squared to the 8th power plus a constant.
So this is 4.5, day 1, and how to solve an integral using u substitution. So if we're going to solve this one, first thing we have to do is find the u, which in this problem would equal 2x cubed plus 5, because it's to the 6th power. And to find du, we take the derivative of this function, which would be 6x squared dx. And since 6x squared is already in the original function, we can just plug it back in. So after substitution, the integral would look like u to the 6th power du. And then the antiderivative would look like 1/7 u to the 7th power plus c, or u to the 7th over 7 plus c. And then when you substitute in the original u for this and find the answer in terms of x, you would get 2x cubed plus 5 to the 7th power, because you're substituting in the original u for this u, over 7 plus c. And that's how you find the integral using u substitution.
The problem we will be doing today is integral 2x plus 5 times x squared plus 5x to the 7th power dx. To start off this problem, you find the u. The u for this problem is x squared plus 5x. After this, you find the du. The du is 2x plus 5 dx. Now that you've found your u and your du, you plug them back into the original equation, replacing all the x's, which would give you integral u to the 7th du. Now that you have that, you would take the antiderivative. The antiderivative is u to the 8th divided by 8 plus c. Now that you have your antiderivative, you can put it in terms of x, which would give you 1/8 x squared plus 5x to the 8th plus c, which would be your final answer.